Hello everyone, this is Neelam Sondhia. I am a software engineering student in International Institute of Professional Studies, DAPP Indore. This is my 10th video. Today's topic is dimensional reduction. Okay, so we will learn about the practical guide by Python and also the techniques of it. So basically, what is dimensional reduction? Dimensional reduction is a crucial technique in machine learning and data science. This is a crucial technique for simplifying complex data set while preserving essential information. Simplifying the complex data set and preserving essential information. This presentation will explore two key dimension reduction techniques: multicollinearly identification and principal component analysis using practical Python implementation. Okay. The next slide. Identify multicollinearity in Python. Okay. Method and description. So there are two methods: correct correlation matrix and variance inflation factor. So correlation matrix calculate the correlation between pairs of feature, means it's calculate the correlation between the pairs of the feature. High correlates close to the 1 or minus 1 suggest multicollinearity. Okay, if the high correlation between these two features close to 1 or minus 1, that suggests multicollinearity. Second method is variance inflation factor, measures how much the variance of a coefficient is inflated due to the correlation with other features. VIF values greater than 5 suggest multicollinearities. Okay, multicollinearities occur when dependent variable in a regression model are highly correlated. This can be lead to unstable regression conflicts and inaccurate predictions. Python provides tools in identifying multicollinearity and address it effectively. This is the Python implementation of it. Practical Python implementation, correlation matrix, and so this is the Python implementation of it and practical Python implementation of correlation matrix that illustrate how to identify multicollinearity using a collinear correlation matrix in Python. We will use the Seaborn library for convenient visualization. So import packages like package pandas as pd, import c1 as snc, sns, import matplotlib. Okay, you can go through this program and you understand the implementation of Python of correlation matrix. This heat map clearly shows the strength and direction of correlations between variables. If you spot high correlations, it indicates potentiality in multicollinearity. Okay, so practic this is the practical Python implementation. Variance, first one is correlation matrix and second one is variance inflation factor. This the variance inflation factor is more precise matrix for detecting multicollinearity. Here Python code is snapped using the state models library to calculate VIFs. Okay, you go through this program is and you understand variance inflation factors. This code generates a data frame containing the IVF values for the each dependent variable. If a VIF value exceeds 5, it suggests a high value multicollinearity for the variable. Okay, the next one is principal component analysis, reducing dimensionality. Okay, the principal component analysis is a powerful dimension reduction technique that transforms a data set into a smaller set or correlated variable called principal component. Means the principal component analysis is a powerful dimension reduction technique. This is most powerful, and that transform a data set into a smaller set. It transforms the whole data into the smaller data sets of uncorrelated variables called principal components. These components capture the maximum variance of data, effectively reducing dimensionality while preserving important information. Okay, uh, PCA is particularly useful when dealing with high dimensional datasets where visualization and analysis can be challenging. By reducing the number of dimensions, uh, principal component analysis allow for easier interpretation, improve model performance, and reduce computational complexities. The next one is PCA steps in Python implementation. Okay, involves following steps. Mean four steps. There are four steps: standardized data, calculate covariant metrics, Eligen value decomposition, and project data onto principal component. Standardizing data, a scale feature to have zero mean and unit variance. Okay, second one is compute covariance metrics to understand the relationship between features and features. Okay, adjacent value decomposition is the exact adjacent value and adjacent vectors from the covariant and covariant matrix. Adjacent vectors represent the principal components and project data onto principal component. Okay, transform the original data using adjacent vector to create the principal component. Okay, this following code demonstrate implementing using the Scalable Python. Okay, this is all about the dimension reduction we will use in data model. We will use in this data model, regression modeling. These all helps in the dimension reduction, which makes our data useful. Thank you for today. We will next